50% of all cases of autism may be due to dampness and mold. And here's the reason why. You see, when you look into the literature, there are multiple theories or concepts around why autism takes place. One is it's an immunological abnormality with either systemic or neuroinflammation. The other line of reasoning is that it's a mitochondrial disturbance. And then the other line of reasoning is that it's a gastrointestinal and microbiome disturbance. The reality is that there is no environmental factor that is capable of causing profound disruptions in all these systems and more other than dampness and mold. And when you look at the exposure rates, which is 1 in 3 of all children are exposed to significant amounts of dampness and mold, this picture makes more sense. But it's more than that. You see, when you look at odd clinical findings that are tied to autism, and all of these are things that I see in the children all the time. You see, for instance, if a mom has history of asthma or allergies, the likelihood of her child having autism goes up twofold. If a child has history of autism, the likelihood of their first degree relatives, their family members, immediate family members having allergies goes up significantly. If a child has asthma early on in infancy and childhood, their likelihood of developing autism later on goes up twofold. Children with autism have much higher rates of allergies, ear infections, food allergies, and eczema and other atopic disease. There is no environmental factor other than dampness and mold that can explain these findings. And the rest of this presentation is going to demonstrate to you how. These children have other abnormal findings. They have a disrupted blood-brain barrier. They have abnormal immune reactions within their nervous system. They have abnormalities in neuroplasticity, abnormal neural circuits, myelination problems, neuronal death, elevations of quinolinic acid and other compounds that cause high degrees of agitation and irritability. The abnormalities in their oxytocin, the abnormalities in their fear response, all of these things could be explained by dampness and mold, which happens to be exposing 1 in 3 children. The disrupted sleep cycles, the restrictive eating, the abnormal vestibular function, which causes these kids to have weird movements and sensory issues, the learning difficulties, the motor tics and EEG findings can all be explained by dampness and mold. These children have abnormal immune systems, and for those children who react to biological stressors, you fill in the blank for censorship reasons, I can't say what that thing is, but that biological agent that's injected into many children, but then when you look at things objectively, we find that there's 99% of the population that can handle this biological stressor fine. They don't have any issues, but there's a small subset of children, especially those on the spectrum, who can't handle these biological stressors. And what we rarely do is say, well, is it the biological stressor that we use? Or is it something about the immune systems of these children that causes them to be vulnerable and susceptible? And I would make a very strong argument, as this presentation will, that dampness and mold creates the immunological susceptibility in these children that then makes them vulnerable to this biological agent, which then causes all kinds of secondary immunological reactions that then causes the manifestation of autism. These children have abnormal intestinal permeability. They have leaky gut. But what's more weird is that their first degree family members also have higher rates of leaky gut. What environmental factor that is in 1 in 3 individuals across this country can cause this finding? Dampness and mold. They have higher rates of inflammatory bowel disease. They have microbiome abnormalities, including abnormal levels of candida. Dampness and mold is capable of causing all of this. There are mitochondrial abnormalities, elevations of reactive oxygen species, zinc deficiency, vitamin D deficiency, and weird things like dental caries. The only thing that can explain all of these findings simultaneously as dampness and mold. And it's not just me saying this. Brilliant researchers like Dr. Thea have been raising the alarm around this long before I got into this picture. If you go and look at his papers extend back many, many, many years talking about this. Dr. Andrew Campbell, who's published over 100 papers on dampness and mold and autism, has been talking about this for many, many years. Dr. Neil Nathan, who's one of the world experts on mold and dampness, has also raised the question. There's so many people that once they come to really understand what dampness and mold does to children, all become extremely concerned. And this is the reality. You know, we talk about heavy metals, and not to say heavy metals aren't a problem, not to say glyphosates aren't a problem, not to say plastics aren't a problem, not to say these environmental factors are not a problem. They are for sure a problem. But when you look at the prevalence of dampness and mold, which is depending on the community that you're in and depending on where you live and depending on the quality of the housing that you live in, somewhere between 10% upwards of 50% of all individuals are getting exposed. And when we say dampness and mold, and I think this is one of the things that's been a misnomer, mold is not just mold. You know, many people think that mold is just the mold spores. Or some people say, well, it's the mold and then the toxins that they produce. It's anything but that. You see, the reason why I keep saying dampness and mold is it's literally a biological soup of toxins, which includes these microbial particulates, these microbial volatile compounds, these bacterial endotoxins that are all highly, highly, highly inflammatory, highly toxic. And as this study says, in combination, these toxins, as they're released into the environment and they behave more like a gas than particulates, this soup of toxins that we inhale can cause horrendous inflammation, horrendous gastrointestinal disruption, horrendous mitochondrial damage, and that is how it causes autism. And here's the reality. We take about 20,000 breaths per day, and most of that is in indoor spaces. So just think about it logically. If you're in an indoor environment where every 90% of the time, 80% of the time, you're inhaling a toxin or a soup of toxins that's capable of disrupting the physiology, especially if you're a little child, what would that do? How would that impact you? And how could that be related to autism? And where we are now with dampness and mold is where we were literally in the 1980s with cigarette smoke, where doctors would come on TV, smoke a cigarette, and say, Camel is my favorite cigarette. I would argue that dampness and mold is likely more dangerous and more toxic than cigarette smoke, lead, or other environmental toxins. And yet we have focused so much on these other environmental factors, and we yet to even talk about dampness and mold. And here's part of the reason why. You see, when you look at cigarette smoke, which is obviously a nasty carcinogen, has thousands of chemicals, heavy metals, I mean, it's awful, right? Everyone knows that. It's obvious. Did you know that trichothecenes, which is one of the mycotoxins that's released into a damp and moldy environment, it's prevalent in all damp and moldy environments, was actually used, literally was used as a biological weapon at some point in time? So imagine, again, cigarette smoke, awful chemical compound, causes all kinds of awful things from heart disease to cancer to all kinds of health risks. Imagine if your child, your newborn baby child, is inhaling thousands, tens of thousands of times, a biological warfare soup of toxins, and trichothecenes was the one used. But imagine if all of these other toxins are not necessarily that much better. Maybe they're not capable of being used as a biological warfare agent. But imagine if the baby is inhaling these toxins that's disrupting the mitochondria, disrupting the gut, disrupting the immune system, doing so much more than all of that. 20,000 times a day. And, people say, well, no, because inhalation of these toxins can't cause harm. And I will demonstrate to you in this rest of this presentation how it can. These are 4 different studies that have demonstrated that when someone is living in a damp and moldy environment, the mycotoxins, these are the only things that were measured in these studies, can get into the bloodstream and can be measured in the bloodstream. There are other studies that demonstrate the same thing for microbial volatile compounds and especially for bacterial endotoxins. And once they get into the bloodstream, what happens? Well, first and foremost, it can get passed through the placenta. So you've got this unborn fetus or child that is growing, and their immune system is getting developed, their gastrointestinal tract is getting developed, and yet they're getting exposed to this soup of toxins before they are even born. What is even more troubling is these mycotoxins, and you would argue other toxins as well, can concentrate in the breast milk. So now that the baby is born, with literally every time they nurse, they get a dose of these toxins. And imagine if these toxins are highly capable of disrupting the gut, highly capable of disrupting the microbiome, highly capable of triggering nasty amounts of inflammation in the entire system. And that is happening to a little baby every moment of every day that they feed until their systems fall apart. And this is the reason why I feel so passionate about this. And I believe everyone needs to be paying attention to this. You see, the little ones are the ones that are getting harmed the most. The little ones are the ones that are least capable of handling this exposure. And there's a moment that their gastrointestinal tract and immune systems literally lose the ability to protect themselves. And that is what we call regressive autism. That moment where these poor parents see their beautiful children lost and they're like, he was talking to me. She was looking at me. She was interacting with me. She was pointing, and now she's gone. He's gone. He can't do it anymore. And I don't know what's going on. That is the moment that these children lose the ability to handle this toxic load. And where biological factors, biological stressors, other things show up into the picture is if you've got a system that's ready to crumble, you add any additional load, any stressor. It's like having a house where the foundation is completely shoddy, the framing is completely lost, and it just takes one strong wind to cause the house to collapse. That is what's happening to these children, and we're missing it. The saddest part is we're allowing this to happen to the people who are most vulnerable. This is a study out of Seattle looking at low-income households. 77%, 2 in 3 of these households had dampness and mold, and 20% of them, when you have obvious signs of water intrusion, that's like heavy amounts of mold. We're allowing this exposure to happen to all of these kids, all of these poor, vulnerable kids, and not even talking about it. When there's a water event, a hurricane, the risk of mold goes up 1 in 2. And about 20% of homes have heavy amounts of mold. Now, you may ask, well, how does that translate into autism risk? This was a really interesting study in 2008 where they looked at what happened in New Orleans. So New Orleans flooded, and they were smart enough to then go look at what happened to the risk of autism in those poor kids who lived in these homes that were flooded. So if a mom was pregnant during the time of flooding, this was the child's risk of autism from essentially no water damage flooding. They were not in areas that were flooded to it happened while the baby was in utero and the hurricane center passed right through it. This is what happens when there is flooding and dampness and mold. Now, the authors argue that this was due to psychological stressors, but I think when you put two and two together, you realize really what was happening is that these children during the womb and early on were getting exposed to high amounts of mold. And you know, in New Orleans, they did not have the means to remediate these homes, which is what's happening across the country and you can argue around the world. This was a review article looking at about 10 plus years of published studies. In almost all of the articles, a possible link between mycotoxins and autism were revealed. And this is just the mycotoxins. Forget about all of the other things. The second article that includes Dr. Thea Herades, exposure to mold and mycotoxins can affect the nervous system directly or through the immune cell activation, thus contributing to neurodevelopmental disorders such as autism. The reality is we don't have all the data, but when you look at all of the indicators, you start seeing how significant this problem is. So why are so few people talking about it? Why is this not more mainstream? You see, it's really, really simple. Dampness and mold are extremely easy to miss on diagnostic testing, on environmental assessments. You've got this mindset that, first and foremost, it's not proven. And this was out of the Wisconsin Department of Health. No case studies have unequivocally documented any kind of relationship between these toxins and any kind of disease risk. So this is the mindset that, first of all, is permeating in the conventional medical community. We're not even thinking about this. And then they're told, well, if you suspect it, you should do IgE testing, allergy testing, to look to see if someone has had exposure and has a mold allergy. Except first, when you look at that and you ask, well, how often do IgE tests come up positive for individuals that have been exposed? And this was a study out of Poland, 400 kids exposed to significant amounts of mold in a school. They found that only somewhere between 2 to 4% of these kids had positive findings, which is very much in line with what I see in these kids over the last 6 to plus years. And these authors go on to say that if anything, this may be more of a delayed immune reaction, which is typically how we end up finding this. So we have all of these methodological flaws, all of these mindset problems where it's not real, you should test for this, except those tests miss it all the time. And then you add to that, we have no FDA approved way of assessing this. It's almost impossible to assess through regular labs. You can't detect these in the blood. You can't detect mycotoxins, endotoxins in the blood outside of research centers. So no doctor can go draw blood and say, let me look at your mycotoxin levels. We can't do that the same way we can for lead. We can't do this the same way we assess for other toxins. Of all of the existing holistic and alternative labs, there's a huge degree of variability and accuracy. For instance, a lot of holistic providers use these tests called urine organic acids, which basically looks at the biochemistry of the child. These organic acids, presuming you use a test that actually looks for fungal markers, and there's only 2 out of many that do, their rates of false negatives are about 60%. So 6 out of 10 times the child could be living in horrendous amounts of mold or had exposure, and this test comes out completely normal. Some doctors use urine mycotoxins, where they're looking at levels of these toxins in the urine. In 1 and 2 times, at least in the kids, these tests will show negative. And because these toxins can also be in food, which then gets in the urine, you can get false negatives. There are blood tests you can use to look to see if the immune system has encountered mold, which are far more reliable. Still not perfect. They still give a false rate in these kids about 1 in 5 times. but more reliable than the others. But sadly, very few providers know how to use these tests. So we're in this conundrum where the exposure is happening, the toxicity is happening, yet people are missing it all the time. And this is one example of a mom and child that were living in a really moldy and damp environment. You can see mom's test. Wow, yeah, the toxins are there. Child's test. Oh my God, no, this child doesn't have toxicity, except they did. These were tests looking in one mom, looking at her levels that were just due to food. And you can see that like they were sky high, and then all of a sudden she eliminated peanuts and gluten and dairy, and levels went pretty much away. There's another problem beyond that. Imagine you had a chain smoker in your wall, in your kid's wall, right? Right where your kid was sleeping, there was a chain smoker constantly puffing out smokes of gnarly biological toxins, except you couldn't really smell it. You couldn't see it. And then you bring someone to come and check your home to see if the chain smoker in the wall is what is making your child sick. And this person comes, well-intending person, who happened to only do a weekend course and is now a mold inspector, comes and checks the home and says, no, you don't have mold. And you presume you don't have mold. You tell your doctor you don't have mold, and everyone presumes there is no mold, and everyone moves on to looking for everything else. This is what's happening to millions upon millions of kids who are being made sick, and we're missing it. There's only one state in the entire country, New Hampshire, that actually requires mold inspectors to be certified. One state. And when you look at how these mold inspectors are assessing environments, they take these mold traps. They're basically little vacuums that suck air in, and then they use a filter paper to check to see if there's mold spores in that environment. And typically what they do is they put one mold trap in a large environment, and then they say, well, let's see if this thing showed something. Except you ask one question: how far do these mold spores travel without someone intentionally disturbing them, aka taking a leaf blower and stirring up the air, which no one does? How far do these mold spores travel? They travel typically a few inches. So if you're measuring something that's 10 or 15 feet away from a contaminated wall, how much of a pickup would you expect to get? Very little, right? Except on top of that, these mold inspectors that are generally not certified, generally took a weekend course, are basically taught to say if the garden outside of the home has more total mold than the inside of the home, therefore there is no problem. Literally, this is their mindset. And here are some examples. Two controls. They took 2 samples from outside and somehow only decided to take 2 samples from the inside. And because this number, not this number, they ignored this one, because this number was higher than this number, therefore it was no problem. Except when you look at the levels of Penicillium and Aspergillus, 2 toxinogenic molds, and Chitomium, which is a very toxinogenic mold, Chitomium here, no Chitomium here. Somehow that wasn't a problem. Aspergillus levels 375, 107, 27. So somewhere between 3 to 10 times the level of toxinogenic molds inside the home, but somehow that wasn't a problem. Here's another sample. Now in this case, they took 2 samples outside. Somehow they were very, very worried about what was the level of mold outside, but they took 1 sample from the entire home. Total mold, 58, 56, more than 43, therefore no problem. Aspergillus counts 35, 29, 25. Chitomium showed up here, not here, not here. Not a problem. This is unfortunately how poorly trained the vast majority of mold inspectors are within our country. And they are missing it all the time. So these children are being made sick, they're falling apart, and we're missing it. And we're allowing it. at a huge financial cost of upwards of $500 billion. And then when you add all of the lifetime costs from loss of productivity, the care these individuals need, comes out to somewhere over $3 million per individual who has autism. And when you total that up, it's in the trillions of dollars. And this is on top of the costs to educate these children and care for them. And we're totally fine paying for all of this. But somehow we're not willing to look at this significant contributing factor that may be causing 1 in 2 cases of autism. And the rest of this presentation is going to demonstrate to you how and why. You see, this conversation is more than just the money. The money is probably the least significant part. Every day, I see families that ask, like, is my kid ever going to be able to connect with me? Are they ever going to be able to socialize and function in society? Are they going to be able to learn? Are they going to be able to function without medications? And what happens to them when I'm gone? Who's going to take care of them? What's going to happen? And this is the reality that millions of families are facing. And it's the most heartbreaking thing to see. And for me, this conversation is very real because this was happening to me. In my childhood and adolescence, very, very likely, not that we could go back and test a home. There was one home where suddenly I fell apart, started becoming disconnected from the world, started becoming suicidal, started becoming highly anxious, and my life fell apart. And I had difficulty connecting. I had what was depression, except it wasn't. I was anxious. I struggled. I lacked the ability to connect. I was highly, highly sensitive, and I didn't even know this was happening to me. So when I see these kids struggle, this conversation for me is very real. I know what they're going through. I felt it. I've experienced it. But the most beautiful part of this conversation is we can prevent it, and we can treat it if we start changing our mindset and making dampness and mold a huge public health priority. How many lives could we help? How many kids could we prevent from developing autism? How many kids who have autism now could we help have a brighter and healthier future? And if we took literally just a fraction, less than 1%, of the money we are spending on autism care, and we just direct it into better understanding what's happening. For $270, there's this wonderful, reliable test called the DUST test that literally for $500 million, every single child who has autism could be tested to see if they're living in a damp and moldy environment. And for $100,000, which is a lot of money, but it's a drop in the bucket in comparison to $3 million of total lifetime cost, we can actually remediate their home. For a few $1,000s, we can install filtration to help these people live in clean environments where they're not breathing contaminated, biologically contaminated air every moment that they breathe. This is a problem that's so easy to fix if we're willing to invest the resources and have the conversations to change it. So I want to now shift gears and help you better understand all of the physiology behind it and also the mechanisms in which this happens. So how does dampness happen? It's really, really simple. You take drywall, you add water, you get mold. You see, when we came up with gypsum board or drywall or sheetrock, we did something really not so intelligent, which is we took calcium carbonate and we put 2 layers of paper on each side. That paper comes from tree bark. Tree bark has mold spores. So we have embedded mold spores into every single new construction that we have built in this country and to some parts around the world. And then because builders are now keen on popping up homes as cheaply and quickly as possible. They cut little corners here and there, which causes water intrusion, which then causes mold. You add to that the poor air sampling techniques, and we have a disaster of a problem that is sitting right underneath our noses, and we are missing it. This is from the Institute of Medicine. The most common method of assessing fungal exposure, which is counting the cultures on these vacuum tubes, have variable and uncertain relationship to the allergen, toxin, and irritant content of the exposure. And why is that? You see, this was a dissertation by Emily Bloom. Based on spore counts, it's very reasonable to say that that is not sufficient to cause health concerns. But the mold spores are not what are making us sick. Because however, indoor molds fragment into very small airborne mycotoxin-containing particulates, which are extremely tiny, and those result in a 500 higher fold larger exposure than previously assumed based on the mold spores. When these toxins are inhaled, they are actually far more toxic than if someone was to inject it into your body because of how it goes right through the lungs, right into different organ systems, causing toxicity. But you get these studies, such as this one by Kelman in 2004, that the animal studies that we have done cannot cause toxicity. There's no way that inhalation of mycotoxins is sufficient to actually cause any kind of mycotoxicosis, is basically mold toxicity. So this is not possible. Based on animal studies, there's no way this could do it. Now, what did they do? They took some rats, they exposed them to one mycotoxin, not all mycotoxins, not combination of mycotoxins plus the microbial compounds, plus the volatile compounds, plus the bacterial endotoxins. They didn't do that. One mycotoxin, large amounts for somewhere between 10 to 120 minutes. And then they asked, did this rat die? Did this rat start bleeding from their lungs? And their endpoint was if the rat died or if they started having bleeding in their lungs, therefore that is reasonable to say these toxins can cause harm. Do you see the problem with this conversation? How ridiculous it is? And then you see other studies like this 2000 study where now they come out right and say, well, these studies have only looked at acute toxicity for only a few minutes, and they've only looked at, in literally every single study that has looked at how mycotoxins through inhalation can cause toxicity and have said it is not true, have only looked at single mycotoxins for short periods of time, to the point where the Institute of Medicine in their book, Damp Indoor Environments and Health, come out outright and say, toxicological studies of mycotoxins are all acute short-term, and chronic studies have literally not been done. And the little ones are the ones who are most vulnerable. Why is this becoming a problem now? It's something that people ask all the time. Why is this a problem now? Mold has been around since the time of the Bible. Why is this a problem now? Well, two things. We've got the sheetrock. We've got cheap building standards for the most part. But then what we also decided to do was now completely seal up the homes for the sake of energy efficiency, which I think is good. But now we have created essentially these enclosed bubbles that do not breathe. So if there is a water event, all of those toxins start recirculating in the air and never get exchanged from the outside. 20, 30 years ago, buildings leaked. The air was constantly moving in and out. That is no longer happening. There's one other factor. We ask, well, how does the body detoxify these toxins? How does the body get rid of all this stuff? It's through the gut. A healthy microbiome, a healthy gut is what is necessary for the body to be able to clear these toxins. And when you add all of the other toxins, and this is where the picture really becomes much more clear. You add glyphosates, you add heavy metals, you add processed foods, you add plastics, you add COVID, you add air pollution. You see, all of these become the perfect setup for this and you can say that it's more than mold to create a problem. Never in the history of mankind have we had such compromised microbiomes. Never in the history of mankind have we had such compromised gastrointestinal tracts, mitochondria, immune systems. All of our systems have become more fragile thanks to all of this. And this is where the exposure to glyphosates and heavy metals comes in. All of those create susceptibility. And then you add to that the exposure of these mycotoxins through the food. And we get to a scenario where essentially what we have done is created the perfect experiment. We have made our population more vulnerable than ever before in the history of mankind in their ability to handle these toxins. We have increased the toxic load thanks to the diet, thanks to the environment, and that collectively is what is causing the disaster to unfold at this unprecedented rate. So now let's look at the odd clinical findings that we see in autism. Let's start with the allergies. You see, they find that individuals that are, for instance, on the spectrum, including those with Asperger's, have these ridiculously high rates of allergies. As mentioned before, children who have autism have a much higher likelihood of having family members that have allergies. And as mentioned, if a mom has asthma, psoriasis, allergies, the likelihood of their child having autism goes up twofold. This was a 2021 study. Link between allergy and developmental disorders such as ADHD and autism have been established in multiple cross-sectional and longitudinal studies. And there's a strong association between allergy and neurodevelopmental disorders. And allergies in early life is a strong risk factor for the development of ADHD and autism. Why? Why the hell would allergies early in life somehow cause autism? Another study, this is by Dr. Theoharides from 2016. Substantial evidence indicates the presence of atopic diseases, allergies, eczema, asthma, increases the risk of autism, and inflammation in the brain may be involved in this pathogenesis. Dr. Theoharides at one point came out right and said, is autism an allergy reaction of the brain? And if a mom, as mentioned, has asthma and allergies, risk of baby having autism goes up. If baby has risk of asthma early on, risk of autism goes up. So what the hell is capable of causing all of this? Kids with autism have a 2 to 3-fold higher risk of having food allergies, food sensitivities. Why? Why? What would cause this? Mold. Dampness and mold. Increased amounts of Aspergillus, one of the toxinogenic molds, if you go back and look at those home tests, increased amounts of Aspergillus was sufficient to induce exacerbations on allergies. Mold exposure has been associated with increased risk of atopic disease, asthma, and runny nose. This was a study out of Japan, 600 individuals who are being exposed to now the microbial volatile compounds, dampness and mold, more than mold. If these microbial volatile compounds were present, which comes from dampness and mold, and they did this through direct testing, their risk of having allergies went up 4-fold. And this is after adjusting for all of this, gas chromatography. This was a study of 50 kids, but what they did in this case is they actually went and inspected every single one of their homes carefully, not just did questionnaires, not just did some sampling. They found that in these kids that were living in water damaged buildings, risk of allergies went up 10-fold. And when you have chronic congestion, guess what that creates? Recurrent ear infections. What do we see in kids with autism? Recurrent ear infections. You can see how all of these data points connect. And if you just look at it objectively without a negative bias, you see how all of these data points connect with one another. This was through the NIH. Infants who live in moldy homes were 3 times more likely of developing asthma later on. Kids who have asthma in infancy and childhood have a 2-fold higher risk of having autism. This was a Rhine study out of Europe, 17,000 individuals. We found that dampness and mold at the home were important risk factors for asthma later in childhood. Another study of 3,000 individuals out of Stockholm. And again, look, you can see they were controlling for just about many of the different factors. If dampness and damp odor and structural dampness were reported, risk of asthma went up 3-fold. These were studies looking at the bacterial endotoxins. Home that has the endotoxins increases risk of wheezing, and repeated wheezing in the first year of life creates the predisposition for asthma and allergies. This is basically how much air someone can breathe in. Exposure to these endotoxins causes airway restriction. Long-term endotoxin exposure in animal studies has caused chronic lung inflammation. When we ask what is capable of causing this distorted picture that causes all of these weird allergic findings, there's only one thing that is capable of explaining that, and that is dampness and mold. The molds directly can cause inflammation in the airways, leading to weird respiratory issues. This was a study of 1,400 kids. And what they found was exposure to indoor mold in the prenatal period. Why moms having weird allergic issues in the last trimester could cause autism. Exposure to indoor damp during the prenatal period can affect the development of atopic disease via immune modulation. Exposure to specific microbiome components, right? So this is basically the fungal makeup of the gut, rather than the mold itself, may be associated with the development of eczema. Now, what is this microbiome component? So basically, these are fragments of these molds that cause abnormalities in the immunological makeup of the gut that can then induce and exacerbate the effect of allergies. This was a study, the same publication, different reference, 300 little babies that had allergies. And what they found was it wasn't just the bacteria, but actually the fungus in their gut that created the susceptibility. Now, how does this allergy reaction influence autism? You see, first and foremost, mold toxins and mold spores can trigger mast cells or activate mast cells. Why is that important? This is a beautiful study by Dr. Theoharides, again, 2012. Perinatal mast cell activation by environmental or allergic triggers can lead to the release of pro-inflammatory and neurotoxic molecules, thus contributing to brain inflammation and autism pathogenesis. And when you get activation of one immune cell line within the brain, you get activation of the entire, I don't want to say the entire immune cascade, but a significant part of the activation of the brain immune response. Mycotoxins not only trigger the mast cells in the nervous system, they also can cause a powerful activation of these immune cells called the microglia, which are the primary immune cells of the brain. And as you see in the bottom, as I'll explain later, endotoxins, these bacterial endotoxins, along with a host of other things, can also compound this effect. And essentially what we have is the mycotoxins are directly activating the mast cells. The mycotoxins are directly activating the microglia. That is causing a lot of the weird things that we see in these children. Sleep disruption early on, the irritability, the food sensitivities, all of those things. And then when we get the disruption of the gastrointestinal tract, these bacterial endotoxins, as we'll discuss later, come into the picture and cause a secondary, almost tidal wave effect, which is what explains regressive autism. Repeated low doses of ochratoxin, a mycotoxin, can cause detrimental brain inflammation. Environmentally relevant amounts of aflatoxin, a mycotoxin, can cause microglial activation. So you don't need gobs and gobs of these toxins to cause this. And these are two studies referenced here. And the reason why I pulled them is to really make it clear, like the amounts that people are getting exposed to within their homes are sufficient to cause this inflammatory response. Now, why is this important? You see, when you add to that the effects of a compromised blood-brain barrier, which mycotoxins can induce, which we see in autism, and then you add to that the histamine reaction that happens from the gut, our poor diet, and everything else, you've got multiple things that are disrupting the blood-brain barrier. So the brain is now vulnerable. This inflammatory response takes place. And you add to that exposure to molds, which can then also cause inflammation, right? So there are multiple things hitting this baby's or child's immune system. And what does that do? It causes autism. The first one is a review article. Several studies now provide evidence that children with autism suffer from ongoing neuroinflammation in different parts of the brain involving the microglial activation. Postmortem studies, PET scans also show the same. Now, why is that important? What controls our circuitry? What controls the circuitry in the brain? What controls neuroplasticity? What controls the wiring of our circuits? The microglia. Microglia shape neuroplasticity and connectivity and wiring. Overactivation of the microglia results in disturbance of proper synaptic development, circuit formation, and social behaviors. What do we see in autism? Exactly this. What is most capable of activating the microglia, hands down? Dampness and mold. Microglial activation can disrupt neuronal circuitry to induce impairment of processing of integration of multiple sensory and emotional inputs. What do we see in these kids? They're struggling to be in the world. They're overwhelmed by all of the sensory information. They're overwhelmed by the emotional information. They can't handle it. Why? Because their circuitry, literally the wiring of their circuits, is disrupted. It's like having a super high-end computer and then some Yahoo comes along with a chainsaw and starts hacking literally the circuit board of your computer, and all of a sudden there are sparks flying out. While it may not be as dramatic as that, I want you to imagine if all of a sudden these immune cells are going and just literally chopping up the circuits, disrupting the circuits, and your child's brain is literally losing its circuit connections, causing all of the weird things that we associate with autism. On top of that, imagine if the coating of the wires, right? There's wires connecting everything. They're stripping the coating of the wires, which is the myelin sheath. So now the wires are sparking with each other, also causing issues. Demyelination is part of autism. Microglial activation, which is profoundly influenced by these toxins, disrupts the myelin sheath. Microglial activation can disrupt the neurons, cause neuronal apoptosis, which we see in autism. It disrupts glutamate signaling. A major role in altered levels of quinolinic acid, which we see in autism. Quinolinic acid is a highly neurotoxic, highly neuroexcitatory compound that basically causes the nervous system to go up in flames. Why are these kids so hyper-excitable? Why are they so overwhelmed? Why can't they handle being in this world? Because their brains are on fire. And their brain is on fire because of something that they're breathing in thousands upon thousands of times every day, and we're missing it. Mycotoxins can directly activate the NMDA receptors, which is part of the glutamate pathway. So on top of the microglia disrupting this glutamate system, the mycotoxins directly can do the same, causing a tremendous amount of excitation. And we give these kids magnesium, and we give them lithium, and we give them GABA. Wouldn't it make sense to take away the toxin that's causing all that inflammation instead of trying to add these supplements? And, you know, when I see families be told, like, oh, well, you should do that, that's like your house being on fire, Except the reason why your house is on fire is because your gas line, your main central gas line, has a massive puncture, and literally just natural gas is going catching on fire. Your house is exploding, and then you're calling, the fire department. You're standing there with your garden hose trying to put out the fire, except you don't understand why your house keeps exploding. Wouldn't it make more sense, instead of trying to dump water on a house that's on fire, to turn off the gas rather than to put out the fire? Except this is what we do. This is how we take care of these kids. We refuse to say what is causing this child's system to catch on fire, because we're not able to test for it. We're not able to see it. Environmental inspectors are missing it all the time, yet we're totally fine doing all of these other things to these kids. These mycotoxins can directly cause apoptosis. They can directly also cause demyelination. So on top of the microglia, you get a direct effect on this. This is all happening while these kids are just trying to develop. And we're missing it. We're missing it, and we're allowing millions of kids to struggle and fall apart because we're too, I hate to say this, we're too ignorant to see the elephant in the room. Microglia can regulate the oxytocin system, and we need oxytocin to form human bonds. Microglia not only regulate oxytocin, but potentially the oxytocin receptors through the release of cytokines. And as noted on the bottom, it's a complex bidirectional relationship. Why is there abnormalities in oxytocin? Yeah, we can give these kids oxytocin. We can pump oxytocin up their nose. Why are their oxytocin systems not working? And I just want to say, all of this, these are not abstract studies that I'm sharing with you. The reason why I've found these studies is because I've seen these in these kids, and as I've learned to regulate the microglia, I've seen these kids normalize their oxytocin, and all of a sudden they're connecting in the world. They're connecting with their family. They're wanting to go up to other kids. Like, the beautiful part of this conversation is when we take care of this, when we take care of the exposure, when we shut down the source of the fire, and we use various things to regulate the microglia, which is entirely doable, these kids are able to connect. They're able to make eye contact. They're able to be in the world. They're not overwhelmed. They're not shutting down. But we can't get to these kids. We can't get these kids to that place until we address the root cause. Stimulation of brain mast cells or microglia disrupts the neural connectivity of the amygdala, which ultimately changes the fear threshold. Why are these kids so overwhelmed? It's because their brain's perception of the world, on top of their sensory issues, which we'll touch on top of their brains being on fire, their perception of what is a threat or not is distorted. And because anger is rooted in fear, some of these children show up with anxiety, and they're fearful. Other kids show up with aggression. It's all rooted in the same thing. And this is a beautiful study from Dr. Theoharides. There's something even more concerning than all of this. You see, when you get disruption in the gastrointestinal tract or activation of the mast cells or microglia, you get a boatload of histamine that ends up in the nervous system. That histamine distorts the sensory pathways. Why are these kids so overwhelmed by sound? Why are they overwhelmed by smell? Why are they overwhelmed by the clothing on their skin? Why can't they handle the texture of foods? Why are they so extremely picky? It's because the sensory pathways are distorted. What distorts their sensory pathways? Histamine. What triggers massive amounts of histamine in the nervous system? Dampness and mold. And you can see, like, all of these things that I'm sharing with you, they're not just one thing. It's not like these kids just have sensory issues. They also have allergies, and they have ear infections, and they have gastrointestinal issues, and they have mitochondrial issues, and they have on and on and on and on. All of this is sitting right underneath our nose, except we're missing it because we're not looking in the right place. Histamine changes the vestibular function, which ultimately regulates our balance centers. It changes our signaling of what we perceive as danger on top of the amygdala. It changes the sensory gating, which is how we perceive the sensory information in the world. Histamine influences sleep. Why do we pass out when we take Benadryl? Because it drops histamine levels. When you get the opposite effect and there's too much histamine, it's like your brain is revving at 1,000 miles an hour all the time and you can't shut it down. What do we see in these kids? They have a hard time falling asleep. They have a hard time staying asleep. They wake up at the crack of dawn and they can't sleep. Why? Because there's too much histamine in their little nervous systems. Histamine also influences food intake. What do we see with these kids with autism? They have restrictive eating. They have disordered eating. They only take a handful of bites, right, of mac and cheese, chicken nuggets, and pizza, because those are the only textures and flavors that they're okay with. And on top of that, their appetite centers are distorted. And that's on top of what the mycotoxins directly do. You see, increased gene expression of anorexia-inducing pro-inflammatory cytokines can cause the condition of anorexia. Mycotoxins can release satiety hormones, which are critical for anorexia. So these kids are not hungry. They literally can't sense hunger. And then on top of that, the texture of food, and I've had normal typic kids who have this say, yeah, the experience of meat in fish is just disgusting. Literally, they're like, vegetables taste disgusting. I hate the experience of it. If certain foods were disgusting to you, and on top of that, you were never hungry to begin with, would you act any differently than these kids? What happens to the mind? This is a study from Dr. Andrew Campbell plus several others. You get all kinds of weird learning challenges, from attention problems to impaired executive functioning. Why are these kids with autism, who are, most of them are brilliant, why can't they do basic things? Because literally their mind is incapable of carrying out these complex tasks. Severe amounts of mental confusion. Drop in IQ points. These kids are brilliant. They have so much potential, but we're allowing this potential to be robbed because we're not willing to have this conversation and understand what is actually causing the problem. Mycotoxins and dampness and mold can cause tick-like behaviors, tick-like movements. These kids have weird abnormalities in EEGs. And what do we see in these kids? A high prevalence of motor tics. Why do these kids have motor tics? Where is that coming from? You see, all of these things are connected by one explanation when we're able to see it. And histamine can further exacerbate the cortical striatal circuitry that contributes to the pathophysiology. So the mycotoxins can directly do it. Histamine further exacerbates the problem. What about the immune system? These were pregnant pigs. They injected Dawn, a type of mycotoxin, into them, and they asked, well, what happened to their offspring? Their immune system went upside down. Increased expression of interferon gamma, interleukin 17, interleukin 10, TNF alpha, all very powerful immune modulating compounds. A decrease in T regulatory cells, so it's like the immune system's brake is taken off. Even in subtoxic amounts, and the reason why I included this is it doesn't take a lot of these mycotoxins to cause these immune abnormalities. Non-cytotoxic concentrations trigger abnormalities in NF-kappa beta, which is a powerful regulator of the immune system. Kids with autism have abnormalities in this NLRP3 inflammasome. Several studies showing mycotoxins can directly influence it. But then you add to that the bacterial endotoxins, which can also influence it. And then you add to that toxins released by candida when it starts misbehaving, which mycotoxins can do. You get this entire picture of how just this one immune cascade, which is powerfully tied to autism, could become dysregulated from this environmental factor. And I would argue no environmental exposure is likely capable of activating this to the same extent as dampness and mold. On top of tripping up the immune system, these mycotoxins can also cause an immunosuppressive effect. So on one hand, you get a lot of excessive inflammation. On the other hand, you also get this weird immune suppression. So these kids are getting sick all the time, and they're having ear infections, and they're getting pneumonias, and they're getting all of these things, and they're getting multiple antibiotics because of that, without us asking what is going on. Why is this happening? As I mentioned, mycotoxins are detoxified through the gastrointestinal tract. So what do these mycotoxins and toxins do to the gut? Where did penicillin come from? Penicillin came from Penicillium. Penicillin is actually a derivative of mycotoxins. Mycotoxins decrease the diversity of the gut microbiome in animals, sometimes permanently. Why do these kids have such strange microbiome abnormalities? Why do these kids have such strange gastrointestinal tract function? Dampness and mold. Mycotoxins lead to marked changes in the chyme composition, basically the environment in which these microbes grow. And the consequences of this leads to dysbiosis. So not only are these mycotoxins and toxins directly disrupting the gut, they're literally changing the environment in which these bacteria grow. That's like trying to grow a lawn, except every day someone that you can't see shows up and sprays acid on your lawn, and you keep planting seeds and you keep watering it, except you keep seeing your lawn die and you don't understand why. That is how problematic and toxic these compounds are to the gut. When the microbiome gets disrupted, it allows candida to go out of sorts, especially if an antibiotic showed up. And remember, these kids have recurrent ear infections, and they have pneumonias, and they have all of these other things going on. So they're getting antibiotic after antibiotic after an antibiotic with a gut that's already vulnerable to begin with. When the intestinal tract is disrupted and the host immune system is suppressed, Candida albicans has the ability to invade and disseminate. And when mast cells are activated, the Candida now colonizes and causes an inflammation. Why is that a big deal? Because that then causes further disruption to the gut. That then further compromises the microbiota, which further prevents them from flourishing, and you get into this vicious cycle that has no end. Candida releases this very problematic compound called candida lysine, which then further activates the mast cell, further damages the cells within the gut, causing further intestinal permeability. And abundance of candida in the gut can lead to asthma. So do you see how all of this picture is coming together? Like, why is it that these kids with autism have distorted microbiomes, abnormal gut function, increased candida, dampness, and mold? On top of what candida and some of those other toxins can do to the gut, mycotoxins directly disrupt the gut. So literally, it's like the gut is glued together by these tight junction proteins, so that it's like the glue that keeps the gut from getting leaky. And imagine mycotoxins are this dissolving agent that literally dissolves the glue and causes all of the cells in the gut to come apart, leading to profound amounts of leaky gut. The children that I see in my practice, and I've been at this since 2008, the kids that I see who have the worst gastrointestinal functions of all, and I've seen thousands upon thousands of kids, the kids that I see who have the worst gastrointestinal function of all are the kids who have had exposure to mycotoxins. In very tiny amounts, this mycotoxins can basically cause these cells to fall apart. And it can actually happen through inhalation. So when we inhale the mycotoxins, they go through the bloodstream, they come into the bloodstream through this basolateral side, and that causes a more pronounced effect on the intestinal permeability than if we were to ingest it, which is why inhalation and environmental exposure is actually far, far more dangerous than anything that we consume orally. Once the intestinal permeability by mycotoxins is occurring, that allows the entry of food proteins. Why is that important? Especially when this happens early in life, even minor changes to a baby's gut barrier function leads to allergies later in life. And that has to do with these food proteins basically leaking through, triggering the immune system, which then causes the sensitization. Why do these kids have tons of food sensitivities? Why do kids with autism have 2 to 3 fold higher risk of having food allergies and food sensitivities? Where is that coming from? What is capable of causing that? Dampness and mold. Like when you look at every single one of the studies that I reference, and again, none of these are abstract for me. All of these I see in kids. Everything that I've pulled together is because I see it in the kids. You see how this entire picture comes together. You get abnormalities in the gut immune response. Now, why is that important? By weakening the gut immune response, mycotoxins make the gut more vulnerable to the translocation of pathogens. Translocation of pathogens is basically the bacteria that are in the gut now are entering into the actual gut itself. The entry of pathogens into the gut, this is a different study, is a key step in the induction and persistence of inflammatory bowel disease. What do we see in kids with autism? Higher rates of inflammatory bowel disease, higher rates of leaky gut, higher rates of gut inflammation, higher rates of food sensitivities, higher rates of food allergies. All of this is due to dampness and mold. Do other toxins, including glyphosates, environmental exposures, air pollution, contribute? For sure. They create the susceptibility. The mycotoxins are like the 1,000-pound gorilla that then comes and sits on the car and just literally causes the car to collapse. This is all of the different ways in which the mycotoxins can disrupt, which we haven't talked about, which includes the mucous membranes and changes in multiple different parts of the gut. When we get a leaky gut, on top of the mycotoxins and the other particulates causing a problem, leaky gut and gut inflammation can directly activate the mast cells in the microglia. There's something way more sinister that also comes about, and this is the part that terrifies me. You see, we have these lipopolysaccharides, which are bacterial surface glycolipids. They're like little fats that hang on these bacteria. These lipopolysaccharides are one of the first things that the immune system in the gut sees. And when you have gut dysbiosis, disruption of the beneficial bacteria along with the barrier, it allows these lipopolysaccharides to get into circulation. And when you have dysbiosis, disruption of the microbiome, these lipopolysaccharides become more toxic. Why is that important? Lipopolysaccharides are among the most potent neuroinflammatory toxins known, and they cause lethal neurodegenerative disorders. The moment we see regressive autism, I believe, and the literature seems to prove and suggest, the moment that we see that moment where these children are lost, they're disconnected, they're gone, is likely the moment where no longer is it the mycotoxins that's causing the problem. It's the bacterial endotoxins that have now entered into the mix. So there's a tipping point. These children are being insulted and they're already inflamed. Their gastrointestinal tracts are falling apart, but their immune system and their gut is holding it together. And they reach this threshold where that no longer can happen. And now the floodgates are open and trillions of bacteria are releasing these lipopolysaccharides that are highly toxic. And there's like this tidal wave of toxicity that hits the child's nervous system and causes a whole higher level of toxicity and inflammation. And that is what we call autism. And what we see is tiny amounts in healthy adults is enough to activate the microglia and cause damage. And then, when we ask, how is it that these children are so susceptible to these biological stressors that are injected? Again, you figure out what that is. Because 99% of kids get these biological stressors and they're fine. So what is up with this 1% of kids, 2% of kids, where the parents say, my child was okay, they got this injection, and now because of this biological stressor, they fell apart? Well, if you add brain inflammation, system immune activation, the microbiome, the gut disruptions, the mitochondrial errors, which we'll talk on, and then you add one more stressor on top of that, wouldn't that be the perfect soup for this to happen? It's like lighting a match in a regular house that has, tile floors and nothing happens, right? Except next time around, you take gasoline and you douse your entire house with gallons of gasoline. You light one match and the entire house goes boom. Children who have dampness and mold have the equivalent of gasoline inside their homes, inside their bodies, just waiting to catch on fire. And it just takes one spark to set this entire house on fire, to then cause these children to fall apart. Dr. Richard Fry and many other brilliant researchers have helped us understand how the mitochondria also play a foundational role in the pathophysiology of autism. And when we ask, well, what is capable of sufficiently disrupting the mitochondria while triggering a weird allergy phenomenon, triggering systemic and brain inflammation, triggering gastrointestinal abnormalities in the microbiome, and causing this collective picture, you can argue that dampness and mold is one of the most significant contributing factors. Not to say glyphosates can't do it, not to say heavy metals can't do it, not to say Lyme and Lyme co-infections can't, but you can, when you look at the literature, you find that glyphosates in heavy metals and Lyme, frankly, don't trigger that kind of allergy reaction. Yes, they can disrupt the gut, and glyphosates can do it in a pretty significant way, but they don't cause this total picture the same way as dampness and mold. And what we find is several studies giving some rather concerning data in terms of how mycotoxins, just the mycotoxins, forget about the microbial volatile compounds and everything else, how mycotoxins alone can cause all of this damage. Every single one of these red arrows are basically one mechanism in which the mitochondria can disrupt, or the mycotoxins can disrupt the mitochondria. Now, what happens when the mitochondria is disrupted? First and foremost, you just get this level of fatigue, which is what we see in these kids, right? They have low tone, they're tired all the time, they're hyper, they're anxious, but physically they lack vitality, they lack endurance, they lack color. Cognitively, the same energy impairment comes at a very high cost, because brain cells, right, neurons, communicate through action potentials. Action potentials require ATP. When there's lack of ATP, literally the way the brain is able to signal and communicate with itself starts becoming slower. It's an oversimplification, but nonetheless, that shows up as brain fog, which can show up as a host of cognitive issues, which we see in these poor kids. There's something else that happens. These mycotoxins, by disrupting the mitochondria, can cause a surge in these reactive oxygen species and oxidative stress, which we see in autism. This can cause lipid peroxidation. Basically, the fat that is in the brain starts turning bad, which is what lipid peroxidation is, which can then cause damage at the cell level. Not only do mitochondria disrupt and damage, not only do mycotoxins disrupt the mitochondria, they disrupt the mechanisms that are required for the mitochondria to repair themselves. So the mitochondria are harmed, but their ability to actually repair themselves is compromised. And it turns out that when this happens, The mitochondrial components act as these danger signals that can trigger additional inflammation, including further activation of the NLRP3 inflammasome and cascades of systemic inflammatory responses, which can then cause further harm. The fatigue, if you want to say, or lack of energy of the mitochondria in the neurons also impacts the traffic control center of the brain, called this paravalbumin interneurons. These are basically the traffic control cops. And imagine the traffic control cops of the brain falling asleep because they're too tired. So you get this energetic logjam or information logjam that takes place. And this is in addition to someone taking a chainsaw to the circuit board and tons of toxicity and inflammation in the brain. As we start putting these things together, we start seeing how autism could be shaped by these very things. And as they go on to say this, deficits in these paravalbumin interneurons are associated with behavioral defects in autism. There's something else that's really weird, which has to do with the nutritional makeup. So not only is the gastrointestinal tract disrupted, appetite centers disrupted, the way these kids eat is disrupted, the mycotoxins, ochratoxin being one of them, can directly cause a iron deficiency anemia. It can actually disrupt the transportation of zinc through the gut, which can cause zinc deficiency. What do we see in these kids? They have all kinds of weird mineral deficiencies. Vomitoxin, which is one of the toxins that's kind of part of the supertoxins that are released, can cause moderate hypocalcemia, and by disrupting this dehydroxylase in the liver, which the body needs to activate vitamin D by 30 to 40%, we also get low vitamin D levels. It's one thing to supplement and say, oh my God, this kid has very low vitamin D. What would cause this entire picture? And I encourage you to go look at how other toxins are able to do this. They can't, at least not to the same extent. There's something even more weird. Kids with autism have much higher rates of cavities than healthy controls. And some people would argue, well, it's because these kids have a hard time brushing, which is true. When you have malabsorption of calcium and other minerals, and they're using the case of preterm kids or celiac, inadequate supply of calcium and phosphorus and the inability of the gut to absorb these minerals are contributing factors to enamel hypoplasia, which basically means weak enamel. Kids with celiac, and you can say dampness and mold, are also at risk for enamel hypoplasia due to malabsorption and mineral deficiencies associated with gut enteropathy, which can happen with dampness and mold. You see, when we zoom out and say, what is the thing that can cause these weird allergy issues and food reactions and asthma, and why would a kid having asthma increase their risk of autism later on? Why do these kids with autism have such high rates of food allergies and cavities and mineral deficiencies and brain inflammation and gut disruption? Not to say that dampness and mold causes all cases of autism, but you can make a very strong argument that there's a very high percentage of what we call autism that could be dampness and mold. And here's why this conversation is so important. It's completely preventable. It's completely preventable, and literally for pennies on the dollar, if we redirect what we're spending on treating to preventing, we could prevent countless cases of autism. Even if you said, you know what, it's not 50%, but maybe it's 10 or 20%. If we could prevent 10 or 20% of autism cases, that would be huge. It's completely treatable. I've had children, level 3 severe autistics that literally could not function in the world, completely overwhelmed, sleep disruption, couldn't eat. Every moment there's a tantrum, they're flipping out, they're being aggressive, they're irritable, they're overwhelmed. They're overwhelmed. And just the other week, there was a dear child with autism who was living in dampness and mold that through their letterboard said to their mom, "My world is shattered. My world is shattered." How many of these kids are just struggling to be in this world? How many of these kids are overwhelmed by the world? How many of these kids are having their lives shattered because of this exposure? And I've had countless cases where we did nothing. We did nothing other than the family just either took care of the exposure, they remediated, they cleaned up, they moved. And 2 or 3 months later, just by addressing the exposure, that child that was aggressive, irritable, couldn't sleep, barely eating, constantly overwhelmed, constantly having meltdowns, high anxiety, started calming down. I mean, sometimes so significantly calmed down to the point where the parents are like, this is a miracle. It's not a miracle. It's we finally took away the thing that was causing their system to catch on fire. And if the child's system is constantly catching on fire and we take care of that fuel source and that fire finally goes out, they're finally able to be in this world. They're finally able to be calm. They're able to function. They're able to thrive. And the most beautiful part is through easy things, widely available antifungals, a handful of supplements. There's so much we can do to help these kids. I've had kids with full-blown level 3 autism, couldn't make eye contact, couldn't function, and then with some of these treatments, 2 or 3 months later, they're going up to other kids and trying to engage with them. They're turning to their parents and saying, "I love you," for the first time. This is what's possible if we start having these conversations and bringing this awareness forward. And if we just took literally 1 or 2% of all that we are spending treating the problem, 1 or 2%, how many kids, how many Americans could have healthy air to breathe in their homes? How many lives can we change? How many kids can we give a brighter future for? How much improvement in productivity can we have? How much of this $6 trillion plus per year, or 6 trillion total cost, could we impact by just helping people breathe clean air inside their homes? You see, if we just start off with doing a simple screening, every child with autism gets a simple screening, and the dust test is a very reliable test, one of many. But for $500 million, every single individual with autism could actually be assessed to see if they have it. For $10 billion, 2%, every single child with autism can have their home tested, cleaned, and filtered. And for mild to moderate amounts of exposure, you can argue that may be enough to control the exposure. If we took that money, 10% of all autistic individuals or children could actually have their homes remediated. How much good can we do by just looking at this problem differently? While we don't know the statistics, you can argue that many of these adult conditions could be in some way, shape, or form also impacted by dampness and mold. We need to turn this into a public health priority. Frankly, it needs to become a public health emergency, because this is how much harm it's causing our society, yet we are completely missing it. And a roadmap of what we need to do is already there. The Institute of Medicine published this beautiful book that lays everything out for us in terms of what we need to do, starting from assessing and monitoring indoor environments, improving regulations and building codes, creating incentives to build healthier homes, disseminating information, creating public health research, collaborating with others to make this all happen. It's all there. It's all there. And we need to change this picture And instead of one state certifying or mandating that indoor environmental inspectors be certified, every state, I mean, why don't we have certification rules in every state? Why isn't this something we're doing? Why are we allowing these things to fall through the cracks at this enormous cost, especially to the little ones who are most vulnerable? My friends at Change the Air Foundation have a beautiful policy brief. There's so much information out there on how to create healthy homes if we just look at it. And this conversation has the ability to change so many lives. You know, at the end of the day, that's what drives me. We can help millions upon millions of kids and adults have healthier lives, have brighter futures, have them be able to enjoy their lives because they're not constantly struggling, they're not constantly sick, they're not on fire, their nervous systems are not on fire. And that starts with you. It starts with you getting this information into the hands of others. It starts with you, if you're in a place of making policy changes, helping to make this become a priority. The information is out there, and I encourage all of you to go do your own research. Go look at this through an objective lens, and you will see for yourself how big of a problem this is. And we need to have a conversation to start addressing this ginormous problem that's costing not just a lot of money, but costing millions of lives. Together, we can create a bright and happy future for so many kids. We can give them their future back. We can give them their health and vitality back. It just starts with sharing this information. So I thank you for taking the time to watch this presentation and to hopefully openly receive this information in a way that becomes meaningful. You all be well. This is Paige McCattery.